Here's the story of the kidneys, and what a story it is. We'll begin with the lungs. They're going to remove carbon dioxide from the bloodstream. The liver, it is preventing the buildup of ammonia, which becomes toxic. And this comes from the breakdown of proteins into amino acids. This ammonia is going to combine with the carbon dioxide to produce a substance called urea. You're going to hear that word quite a bit in this lecture. The kidneys, their job is to filter water and solutes, except for the proteins. And they're going to take this from blood. They also reclaim water and excrete toxins from the bloodstream. Urea and other toxins exit through the ureter. Okay, that's the overview. And I'm going to go through these step by step. The urinary bladder is just a temporary storage for urine, which eventually is expelled from the body through the urethra, that is below the bladder. Kidney major regions, the cortex, that is an outer tough coat, and it's a good thing, but it can become a problem I'll talk about later. The cortex protects the fragile nephron tubules that are in the medulla. Take a look at this diagram. The outer cortex, these inner triangular areas, that's the medulla. This is where the tiny nephron tubules, these are the big stars of today's lecture. That's where they're located. The renal pelvis is just a collecting area for urine, and from there it's funneled into the ureter. Basic function, well, I've broken it into steps. The first is filtration. Blood's going to enter the kidney from the renal artery, and this is going to branch in the medulla and cortex. So remember, the cortex is the outer part. A small blood vessel called the afferent. Now, afferent means carrying towards. So here's an arteriole that's going to bring blood into the kidney to each nephron. In the outer cortex, the afferent blood vessel is bringing blood into a cluster of blood vessels called the glomerulus capillaries. Now I'm going to use this word several times. We're going to take a good detailed look at it. So at this point, I'm just setting up the players of this story. Now this is where the blood from the body that needs to be filtered first arrives. It's going to arrive at the glomerulus. And the glomerulus is the first part of the nephron. At this point, you might get a piece of paper and a pencil and try to sketch some of the steps, because at first it's going to look very confusing, and then once you learn it, you'll think, oh, this is really simple. The glomerulus is a swollen capillary, and it has slit-like pores. These are tiny pores, and they're so small they'll allow water and solutes, such as small particles in the blood, to squeeze out of the capillaries. The glomerulus is so fragile, it's protected. It's surrounded by a Bowman's capsule, if you look at the diagram here. Now the large solutes that do not flow into this Bowman's area, they're going to leave the glomerulus through the efferent arteriole. E, think of E, exit, right? Efferent means carrying away from. So take a look. We have an afferent going into it. The large particles, they're going to go right into the efferent and leave the whole area. And that's a good thing, because we don't want to urinate out large substances such as our body's cells. We don't want to urinate red blood cells or white blood cells. And that's the job of the glomerulus, is to keep those guys from entering the urine. The blood pressure is going to force blood and squeeze it through the pores of the glomerulus. Now don't let me lose you. Remember, the glomerulus is the first part of the nephron tubule. And we'll take a look at that tubule shortly. The pores are too small, I mentioned this, to allow blood cells and large solutes, such as proteins, in. Good thing. And these are expelled from the glomerulus. They enter the bloodstream, and we get more use out of them. But what about the small solutes, such as glucose, amino acids, sodium, urea, and water? they're going to flow from the afferent, remember A means towards, into the nephron tubule. So finally, we're going to get into that tubule where the filtration takes place. Of course, it has to pass first to the glomerulus. So take a look at this diagram. Glomerulus, and that is the first part of the nephron tubule. Reabsorption. This is the next phase of filtering of blood. We're now in the nephron. All right. So take a look at the nephron. Is that yellowish tube here? It's surrounded by blood vessels. The substances are going to be pumped out of the nephron tubule. Why on earth do we do that? Well, these are substances that we want. And so the nephron tubule is surrounded by blood vessels, and these vessels are called the peritubular capillaries. Peri means around. And that's because the body can't afford to lose large amounts of water and nutrients. And so thankfully, we're going to dump the valuable goods from the nephron into the peritubular capillaries. Remember that white sheet of paper? It's a good place to make a simple sketch. The nephron tubule walls are only one cell layer thick, at least in this part of the nephron, and so this allows substances to diffuse in and out of the tubule. Okay, it's very permeable. Most of the useful substances in the fluids have been filtered out by the time this filtrate arrives at the distal tubule, and that's the final section of the nephron tubule. I have it labeled here. So we're going to go through that whole tubule, go down and come back up, and then when we get to the distal, there's not much there we want anymore. The loop of Henle, also called the descending loop, it is surrounded by extremely salty fluids, and this is going to create a diffusion gradient so that water flows outward from the tubule. This makes sense because our body wants to conserve water. You see, thousands of years ago, we didn't have drinking fountains, and who knows when our next drink of water would be. So these nephron tubules are so efficient extracting water from urine. So the urine is going to become more concentrated until it matches the surrounding fluid. On the ascending loop, and that means going upwards, the walls now are thickened and they're not going to allow water to leave. But now salts are pumped from the nephron, and this is one of the ways that we conserve our electrolytes. These are charged particles and mineral salts. We want to keep those, and this is how we do it on the ascending loop. Nephrons are extremely efficient. Most of the reabsorption takes place in the first part, which is called the proximal tubule. Proximal means near. Average daily reabsorption, glucose 100%. Amino acids 95. Okay, those come from proteins. Sodium ions 99.5. It's so amazing, and it's ridiculous when I saw a survival show, and out in the desert these guys were drinking their own urine. Obviously, they had no idea how insulted their kidneys must have been, because they said, well, I just finished with that. This stuff is perfect. Urine is amazing, especially when we're dehydrated. There's not much water available in that urine. Nothing in there we want anymore. Small particles are going to diffuse from the nephron. Okay, we're still trying to save what we can. Amino acids and other large particles have to be pumped through transport proteins, and that's because amino acids are large, and so we can't just follow a gradient, a diffusion gradient. We have to actually pump them, and this is another way we save valuable nutrients from being expelled in the urine. Nice little diagram. Nephron tubule, diffusion into peritubular. Those are the ones surrounding the nephron. Secretion, now we're in a third step, and this is where we want to deal with some unwanted substances in the blood. They're going to diffuse out of the peritubular capillaries into the nephron tubule. So understand, this is the opposite direction of everything I've talked about so far, because up till now, we're dumping unwanted substances out of the nephron tubule. Here's kind of our last chance to dump anything in the bloodstream that we don't want. Things such as excess hydrogen, potassium, certainly urea, drugs, waste, other chemicals are going to get dumped in this last step of the nephron processing. Finally, urine is going to leave the distal tubule of the nephron flowing into the renal pelvis. Renal pelvis is just a collecting area where other nephrons are dumping their liquid waste, and that's going to flow into a ureter and eventually into the urinary bladder. As pressure in the urinary bladder increases, the internal urethral sphincter is going to relax, and these smooth muscles are under involuntary control. Urine's going to leave the body when the external urethral sphincter relaxes, and this is voluntary control. These are skeletal muscles. If you look at the diagram, you'll see how that works. Now, for you guys, if you really want to empty that bladder, you got to sit to pee. You sit and lean forward, and you can expel the contents. Much better than if you stand at a urinal and pee like a horse. So, if you want to empty that bladder, sit, lean forward. It's not just for the women. Urine concentration regulation. There are ways that our kidneys conserve water, and other times they don't. They're under the control of the anti-diuretic hormone, just called ADH. This is going to affect the distal tubule. If you remember, that's near the end of the tubule. It's going to cause water to move out of the tubule into the bloodstream. Now think about this. If we're pulling water out of the nephron and into the bloodstream, then that's going to increase blood volume, and it's going to increase blood pressure, which is really slick. People don't realize that the kidneys have a big control over blood volume and blood pressure. Nice little diagram. Water loss reduces blood volume. There's sensors in the brain, and they're going to trigger the release of ADH. ADH works on the distal tubule, and now they're more permeable to water. The kidneys are going to reabsorb more water, so less water leaves in urine. Blood volume rises, and that it rises because we're pumping water out of the distal tubule. Finally, receptors in the brain detect an increase in blood volume, signals ADH secretion to stop, and we have a wonderful negative feedback loop as long as the kidneys are functioning as they should. Acid-base regulation. So not only do kidneys affect blood volume and blood pressure, but blood pH as well. When the blood becomes too acidic and they have a high concentration of hydrogens, then the cells of the nephron tubule are going to form bicarbonates. Now you've seen that word before. It's in the saliva, it's in a lot of places in the blood as well. Bicarbonates are going to diffuse out of the nephron into the bloodstream, and now we're going to buffer the acidic blood and bring that pH closer to a normal level for the bloodstream. Nice little review here of filtration, reabsorption, and secretion. Major steps. Remember that piece of paper. Try to fill this out and test yourself on it. It's not so difficult. Review here. Pre-kidney work by lungs and liver. Kidney, a little bit of anatomy there, cortex, medulla, renal pelvis. Filtration, that's step one, and that's where the renal artery and the afferent going towards the nephron. The glomerulus is that big swollen capillary with slits in it, surrounded by abomens and cells, water, and urea. Well, they're going to be filtered. Some get filtered out. Certainly the cells don't go in, but the water and urea do. Reabsorption, this is stage 2. This is when the substances we want are being absorbed by the peritubular capillaries that surround the nephron. There's a proximal and distal part of the nephron. The descending loop, or loop of Henle, is where salts are concentrated, and so water is going to move out. Reabsorption, continued. Salt, okay, I mentioned that. Electrolytes, this is where we conserve our electrolytes. We need those. We don't need to drink Gatorade. We have our own electrolytes as long as we stay hydrated and our kidneys are functioning well. Secretion, that's where our peritubular capillaries are going to dump, and this is the reverse direction. They're going to dump excess hydrogen, potassium, urea, drugs, waste, chemicals, our last chance to dump things out of the bloodstream that we don't want. We've created this perfect urine, and it's time to expel it from the body. Goes the renal pelvis, urethra. The sphincter is going to control the expelling of the substances. There's an internal and an external. Finally, regulation. ADH is a big player in the distal tubule that influences blood volume, blood pressure, and kidneys also affect blood pH by releasing bicarbonates into blood. Wow. Take some time and learn this. It's really quite a story. I think you'll enjoy it when you get it all figured out. Good luck.